All right, now let's take a look at our displacement time graph. You'll be able to see displacement up here on the y-axis and time in seconds over here on the x-axis. So the first question is asking us to find the displacement after 16 seconds. So what we're going to do is go over to our motion graph, look on the x-axis at time in seconds, and all the way over to 16, and we'll follow the line right up until we meet our point. Then after that, follow the point to find out which displacement is associated with the time at 16 seconds, and we see, well, it's 16 meters. So the answer, first question, is that the displacement is equal to 16 meters. Now there's one more important step. That is that the displacement is actually a vector. You can see what's important over here as we see this n. That is a direction, stands for north. So in our answer, it is going to be important that we include the units. That's north. All right, so that is part A. Moving on, it asks for the distance traveled after 16 seconds. Now you'll see there's a difference between distance and displacement. The displacement is the vector, so it only refers to, well, it refers to a distance traveled with a direction, whereas the distance without a direction is something completely different. So how we're going to measure that is find out how high we go. This is 20 meters north, and then we start going south 4 meters. So for the total distance, we are looking at adding 20 meters plus 4 meters. That is, hope we can do this without a calculator, 24 meters, and there's no direction associated with distance. Now, the instantaneous velocity at 4 seconds. We're going to come over to our graph here. Here's our dot at 4 seconds, and we need to know what's the instantaneous velocity. So another word for instantaneous velocity is the instantaneous slope, which tells us when we see this, you want to instantly think, okay, we're going to use the tangent line. And if you remember how to do that, we want to draw a line that just barely touches the curve. So at 4 seconds, when we draw our line, it'll look something like this. So you can see the important part is it's just barely kissing that green line. Okay, now to do our calculations. The velocity is equal to delta D over delta T. And that is, so the change distance of the change in time. So on our tangent line, we're going to find a clean spot. That's like this. That's got a nice number for the meters. That's 8 meters. I'll write it over here, 8 meters in 10 seconds. So that's our final spot. And our beginning spot here, 2 meters, 4 seconds. So our change in distance will be 8 meters minus 2 meters over 10 seconds minus 4 seconds. And again, do this in our head. 6 meters over 6 meters, which is equal to 6 meters over 6 seconds is 1 meter per second. So it just so works out we're doing exactly 1 meter per second. One more important step, if we look at the question here, there's 2 significant digits, so we want to have 2 significant digits in our answer. So 1.0 meters per second. And if we're looking at our previous ones, we should actually make that change as well. Since the questions have 3 significant digits, our answers also should have 3. Okay, moving on to average velocity over 16 seconds. So we have a formula for the velocity average is equal to change in displacement over change in time. Now, what number are we using here? Average velocity over 16 seconds. So we're going right to the end, 16 seconds. And we need our average velocity. So again, same line as the orange one. We've gone 16 meters, and we did that in 16 seconds. So distance 16 meters over 16 seconds. Now if we want to go according to the formula, you could add your minus zeros because our other point is technically the 0, but it's optional. You can just write 16 meters over 16 seconds if your second point is that 0. Once again, this equals 1 meter per second. And we have 3 significant digits in the question, so we want 1.00 meter per second. That's the final answer. Average velocity over 7 seconds. This one's going to be a little bit trickier because we're going to have to go in between our lines here. So how many seconds? 7 seconds. That's right here. And we're just going to follow up until we reach the green line. There's our spot. Now read it across. It's at 10 seconds. Once again, the formula is the same. Now we have 10 meters. We did it in 7 seconds. If you'd like, you can add the 0 because we are tracing it back to the 0 because it's asking for the average velocity. So this is 10 meters per 7 seconds, which is equal to 1.42857 meters per second. But we just want 2 significant digits, so our final answer will be 1.4 meters per second.